Hey again, sixth grade scholars. Well, today we're going to continue with Measures of Center. So this is lesson number 2, SOL 6.11b. I'm Miss Terry, so let's work on math at Terry's house. Our objective of the day, I will be able to determine the impact on mean when data changes, and we're going to be using Desmos. So supplies you will need today, our notebook, our pencils, and of course our Desmos application. So go ahead and gather your materials and let's go ahead and get started. So from our independent practice on yesterday, here are our solutions. Our mean was 49, our median was 45, and the mode was bimodal with 45 and 60. So please check your answers and see if they were correct. And if you made any errors, see if you can go back and determine where your errors were and correct them. The second part of our problem was, what might you suggest about the amount of time she walks daily? I just randomly place some information here. Yours can be a totally different. Maybe she had a rough weekend and she just needed to just get some walking in, but just not a lot, just to get her, legs pumping for the day. And that the maximum time she walked based on our data is 60 minutes. So again, your answer may vary from mine, and that's totally okay. The other part, though, was think about what may occur if she only walked 4 days versus 5 days. What central tendency may change? Why or why not? What other questions might you have? These are some of the things that we're going to talk about more in detail today. Or just a number that just doesn't seem to fit. It's just like it just doesn't seem to work well in that data set. So we think about that. It's like, I don't really know. So let's see if we can figure it out. So this is what we're going to discuss. Changes to data and the impact on central tendency. So first, I just want you to think about it, and then we're going to do some calculations. So Tiara earns the following scores on her math test. What is Tiara's average score on her math exams? What are we looking for? Thinking about our central tendency? The other word for average? You guessed it, mean. So her scores for quiz 1 was 80%, quiz 2 90%, quiz 3 72%, and quiz 4 was 80%. So first, I just want you to kind of go back to your Desmos, and I want you to pause the video and then determine what was her mean score for her 4 data points. Once you're finished, come back with us and we're going to do them together. Okay? Great. Welcome back. So I'm going to go ahead and pull up the Desmos app, and I'm going to move it over so we can just see our scores. And I'm going to go ahead and split this screen so we can continue to see all of the questions as well. So here we go. So remember from yesterday, we went to function. We went down here to mean. And then we went back to main so we can get our numbers in. So here we have 80, and between each set we have the comma. And I'm doing this way so that you can see me placing each number in our Desmos calculator. And then I'm going to close it. Again, I don't have to close it, but I like to just close my set just to get comfortable with ensuring that I close it each and every time, regardless of what type of mathematical problem that I am doing. So for this data set, we should have had a mean of 80 and 5/10. And that will be percent because we're talking about average of her score and it's in percent form. So 80 and 5/10%. Great. So the second problem says Tiara completes quiz corrections. Yes, she has a wonderful teacher to allow her to do some quiz corrections. And it raised her score 8 points. That was based on quiz 3. So she went from a 72 to an 80. So what impact do you think this will have on her overall average? Now, take about 30 seconds. I'm going to pause. You pause the video, jot down about, 2 or 3 different things about what impact you think that would have on her average. And then come back with us and we're going to kind of discuss it. Since she went up, her average went up on that particular day from a 72 to an 80, then I think her mean probably would go up too because the number is higher. And I tend to agree with you. So let's go and see, though, if our conclusion is right. So let's see if that is correct. Let's see if our thought process is correct. So number 3 says, find Tiara's new average score after she completes her quiz corrections. So we're going to go ahead and replace this 72% with an 80%. So this is where I want you to look at. And we're going to do this 2 different ways. Pay attention to, I'm going back to the decimals calculator, and you see since I'm going to change her score from a 72% to an 80%, I can simply change this number here. So I'm going to click on the 72 and I'm just going to delete that number and place in the number 80. Place in the number 80. And what happens? I get an 82 5/10%. That is one way I can do it. So in the Desmos online calculator, you can just make that simple change. Or if you want to physically see the difference, if you want to see what happens, I'm going to go ahead and change this back to 72. Of course, I can go here and I can do the same thing that I did before. I place in my function, my mean, and then I can just place my data. This time I'm going to use the keyboard, so you're not going to see me using that. I'm going to use a keyboard, 90. And then I have 80 because I replaced the 72 with 80 just so I can see the difference in my number. And I get this, I get 82 5/10%. Because remember, this is going to be in percent form. So I have 82 5/10% as my change. It's the same thing that I had. This is my original data. This is my data when I change it from 72 to 80. So again, I can see the difference here, or again, like I did before, you can change that 72 to the 80. So either way works. I just want you to be able to look and see, but you got to make sure you're differentiating between your original data and your changed data. Okay, so that's one way. Very good. Excellent job with that. All right. So what we stated, our hypothesis was correct, that we thought that it was going to go up, and our conclusion was perfect. Excellent job. Good job. So let's go ahead to this one. So for this particular problem, I want you to try it on your own. Again, pull up your Desmos, and remember, you can clear it out by hitting clear all, or you can just hit the enter and you can keep the data going. So the first one says, find the mean of the data set. And you have your data set above. And then for B, if the 4 6/10 is changed to 6 4/10, what would happen to the new mean? Think about that. And then explain how the mean changed in part B. So you want to write what would be the new mean, what will change, and what do you think happens, okay? So go ahead, pause the video, and then we're going to come back and check your answer. All right, welcome back. So we're going to do a couple of things before we go through that answer. Now, this is where I want to be very, very clear on what you're going to be looking at. I want you to make sure you have your data set already. All right, you have your data set nice and clear in your up here as well, so it's already written down for you. However, you're going to need to have, you can create 4 lines in your notebook, but I want you to have 4 clear, distinct positions because we're going to do some different things for this set, okay? So we're going to see what happens. We already changed the data. So the first thing you had to do is you had to change the 4 6/10 to 6 4/10 to find what the mean of that data was. That was the previous slide. So now we're going to see what happens if we add a piece of data. Let's add a piece of data and see how that impacts the mean. So let's add 16 7/10 to our original data set up here. And you may be saying to yourself, that doesn't sound right. Seems a little high based on the data that we already have compiled. It does. I absolutely agree with you. So this is an outlier. And an outlier is a value that just tends to seem like it's either, far away from the rest of the data. Okay, it's really, really high or really low. It just seems like it's out of the way. So that's what an outlier is. So go ahead and pause it and you can write the definition of what an outlier is. Now, so we're going to go ahead and calculate the mean with our 16 7/10 with the original data. So remember, the original data is here. So we're going to add the 16 7/10 to the original data. So again, pause the video, go back to your Desmos, and find the mean with this additional piece of data. Once you're finished, come back. No, we're not quite done. So go ahead and pause it and come back when you are done. All right, now, one more thing. Let's see what happens if we remove a piece of data. So let's see what happens if we remove a piece of data. So let's go ahead and remove the 4 6/10 from the original data set. So we're going to go back to our original data set here up here, and let's remove a piece of data. So instead of the 5 pieces, we're only going to have the 4. So we're only going to have these 4. And I want you to now determine the mean of just those 4. So again, go back to your Desmos application. If you have it on a split screen, great. Go ahead and figure it out and then come back when you are done. So now you should have all of that information ready for us. You should have the original data. You should have the change data from when we went from 4 6/10 to 6 4/10. You should also have your data from the original when we added the 16 7/10, that outlier. And then you have the last piece, which when we removed a piece of data. So that's all of the things. You should have 4 answers on your paper. So go ahead, pause it. Make sure, go back, check your answers one more time. Always good to check them twice. And then when you're done, come back and join us. So let's check it. Here we go. All of your answers are there. So let's see what you received. Let's see. We have our original data. Our mean is 6 32/100. Okay. We have our mean with the data change, which was 6 68/100. And that kind of makes sense. So we went from the smallest number and then we added a higher number, then that means our mean should be a little higher. Okay, makes sense. Same thing with this outlier. So we went from our numbers being fairly around the same to this outlier number, which means our mean should be a lot higher because it was a higher number. It was a larger number. Then we went to removing the lowest number there, and therefore our mean became a little higher as well because we took out the lowest number that we had that may have impacted our original mean. So this is what I want you to write down in your notebook. Adding or removing a data point will affect the balance point. Okay, it will affect the balance point because and it also could change your median and your mode. Okay, so just be aware of that. And when changes occur with an outlier, that number that just seems so far away from the rest of the numbers in our data point, that the mean will be affected more than the median, because an outlier just throws the mean completely off. But the median, because we're talking about the middle number, once our data is in numerical order, that middle number won't be impacted as much. All right. So please write that down, and we're going to keep that in mind as we move throughout our lesson for the week. Over here, it would have looked like in your calculator. So changing original data, changing a 4 6/10 to 6 4/10, adding in our outlier here. So it went from the 5 pieces in our data set, 1, 2, 3, 4, 5, to the 6, 1, 2, 3, 4, 5, and 6, and then removing the data point, and it changes from 5 to 4. Okay, so great job. Again, as always, check your work. It may have been an error in which you inputted as far as our data set is concerned. Just make sure you check your work. So pause it, check your work, and see if you made an error, and then go back and see if you can determine where your error was and fix it. Awesome job. Great. So here's your independent work. So this is what you're going to do. You're going to do basically all of the things that we worked on today. So you're going to do the things that we worked on today. So I'm going to move this over. So what we're going to be looking at here is changes to data, the impact of the central tendency. Same thing we've been doing. This is based on some temperature trends right here in RVA. Now, this is not current data, but I want you to look at it. So the problem will be, look at the weekly temperatures to the right. And on Sunday, the meteorologist predicted a warm day and that the high will be 76 degrees. What impact do you think this will have on the mean, the median, and the mode of the data set? Okay, so we're going to do some things we did yesterday, but then we're going to think about how this is really going to impact all of this. First thing I want you to do is I want you just to find, just like it says, our first set of data, which is Tuesday through Saturday, and you're going to find your central tendency on your data based on those days. Perfect. We're going to focus mainly on the mean, but you can go ahead and find your median and your mode because that should be fairly simple from what we did on the previous day. Then you're going to look at your data set from when we add in this additional day from our meteorologist prediction. So that's going to be Tuesday through Sunday. And you're going to do the same thing. But don't forget to answer the question, what impact do you think this will have? What impact do you think this will have on your mean, median, and mode? Awesome. We're almost done. First, I want to ask you a question. Are you able to determine the impact of data changes on mean? Yes, awesome job. I think we have it too. So don't forget to spend about 10 to 15 minutes in your Dreambox account. And then you are done for the day. So don't forget to do your independent practice, and I will see you scholars on our next session.